Hi guys, I hope it's going well. We're on to our fifth lesson for this final unit. And this lesson we're going to get away a bit from sequences and look at what are called series, which is really kind of a modified sequence anyway. But before we do that, there's a little warm-up question. You can try this one out. Try not to look at the answer if you're trying it yourself. Otherwise, I'll just quickly go through it. This is one of those ones, so you can pause the video, obviously. It says find t of 8, so the 8th term of this sequence. So in order to do that, we need to recognize first that it is indeed a geometric sequence. So that means in order to do that, we want to take successive terms and divide them by each other. So like T2 over T1 should be the same as T3 over T2, or the ratio of terms should be, which should be the same as T4 over T3, and so on. And if you do that, you find that you're multiplying each term by -1/4. And the other information we know is the first term is 256. We want to find the value of the 8th term, and we know the number of terms is 8. So we sub that into this formula, a times r to the n minus 1, and we just work it all out and should get a negative number because we have an odd exponent, and we do. Great. Okay. Hopefully that's okay. So today, as I said, we're going to look at series. And so a sequence, remember, is just a list of ordered numbers that fit a pattern. And that pattern has a common difference if it's arithmetic, or a common ratio like the one above. Ratio can also be thought of as a multiple. And what we're going to talk about today is when you take that sequence and you add them all up, and that's what a series is, which is the sum of the terms of a sequence. So, just like before, there's some notation to be aware of. Instead of t sub n, we use s sub n for sum. So s for sum. And whatever the n is tells us how many terms we're going to add up in starting from the first term and going up by 1 each time. So s sub 10 would be the sum of 10 terms. And often the way you write series, so if let's say I had a sequence here of, make it simple, 2, 4, 6, 8, and so on, dot, dot, dot. A series would simply take those and add. So instead of a comma, you put addition plus dot, dot, dot. But eventually you would need an n, otherwise it's an infinite series, and that's something you'll learn in calculus if it is an infinite series, but we're not doing that. We're just looking at... So there's a little story that goes along with the derivation of this formula. And the story is one of this handsome-looking fellow here, who is this guy here with the nice hat, was Carl Friedrich Gauss. If you wrote the math contests in grade 7 or 8 through University of Waterloo, they are called the Gauss math contests. And he contributed a whole bunch of things to math, and he was somewhat of a math prodigy, one might say, like many of you are. But the story goes that when he was in elementary school, he was quite young, and the teacher wanted to keep the students busy, so he said, why don't you add up the numbers 1 to 100 and come back to me? And within a few moments, this Gauss child came up with the answer, and everybody else took forever and got it wrong. And what he did was he thought of patterns and sequences, and obviously this fits into the unit, but he took all of the numbers. He noticed if he arranged them over top of each other, so the top line in ascending order and the bottom line in descending order, like this, and if he added them up, and you don't necessarily have to do this yourself, but if he took each one over top of each other, so 1 plus 100 is 101, 2 plus 99 is 101, and so on, they're all 101. He found that, well, he could easily make a multiplication, which is 101, and there's 100 numbers. Only he's double counted because he's got this line and this line, so we got to divide by 2. And so he came up with the sum of everything. So the sum of the first 100 terms that go up by ones is just 5,050. And I think it was at that time that they realized he was some sort of genius dude. And eventually he went on to, and this is the old German Deutschmark here. And he added things into stats like the normal distribution, also the Gaussian distribution. And if you go on in math, you'll learn a bit more about them. And so this was a couple hundred years ago, just over a couple hundred years ago. Anywho, a little story time. So what we're looking at is the series, and we're going to use a formula rather than take Gauss's method. Our formula will make it a bit easier. And basically, we said that an arithmetic series is just the sum of the first n terms of an arithmetic sequence. And just to refresh your minds, in an arithmetic sequence, this was our formula, where we had A is the first term, N is the number of terms, and D is the common difference. What we can do is take that and use kind of Gauss's method and come up with, and this is the formula we're generally going to use. This is the sum of n number of terms. So this is the sum of n terms. And n is the number of terms. And then the other stuff you've already heard of. A is the first term's value. D is the common difference. So we're going to use that formula in order to figure things out. So let's just try that. So the first one here, it says determine S sub n, so the formula, and then we're going to find S sub 15 for this series. So we've got this series. It looks like it's going up, if you check it out, by 3 each time. Remember, you can always take T2 minus T1 and T3 minus T2 and so on to figure that out. So our common difference is 3. A is always easy. That's our first term. And eventually we're going to have n is equal to 15. But for now, let's just get the general formula. So S sub n, I'm going to write it out again. So that's that formula we put in a box. Like that. So if I wanted to sub these things in, not the n yet, but sub in the a and the d. So I got 2 times 3, 2 times 2, sorry. N minus 1, and then d is 3. So we'll just simplify what's in those brackets. So we've got 4, I'll distribute this 3 into there, plus 3n minus 3. So this becomes 1 plus 3n, like that. So there's my general formula for the sum of this specific series. So if I wanted to find the sum of the first 15, I just sub in 15 wherever I see n. And so if I do that, that's 15 over 2. This is going to be, I guess, 46, which comes out to, if we plug that in, 345. So the sum of the first 15 terms is 345. So pretty straightforward to use the formula. But you can get into these situations where, like this one, it says find the sum of this series, but it has a final term. And this final term is the nth term. What we don't know is what number is n. How many terms are there in the sequence? And so if we write down what we know, so a is our first term, so that's easy again, 9. Looks like we're going up by 4s. So d is 4. Our nth term, or t sub n, is 245. What we don't know is n. So to start this question, we have to go back to our sequences formula and figure out the number of terms. So again, our sequence formula looks like this. And we sub everything in and solve for n. So remember, distribute this guy in. So we've got 245 equals 9 plus 4n minus 4. And if we rearrange everything, I'm going to get 4n equals 240. So divide by 4, and that gives me a number of terms, which is 60. So now we have the number of terms, and we can find what they asked, which is the sum. So we're going to use the sum formula in order to do that. So I'm going to just sub it all in right off the beginning. So I got the sum of 60 terms equals n over 2, which is 60 over 2. 2 times a, n is 60, d is 4. And really you can punch that all in. I'll break it up into a couple steps. So this becomes 18 plus 236, and I'll do that one a step. The sum of 60 terms is 7,620. Like that. So we use something from earlier in order to figure out this sum. So other things you can do with this. This one, it says finding the number of terms. So it says determine the number of terms of the arithmetic series whose sum is this. And we are given T1 and D. So let's break down what we know. So we want the number of terms they're asking. So S sub n is 629. That's the sum of the number of terms. A, so this guy is the same as A, is 5. And D is 4. Again, we're looking for n. So if we take our formula, I'll just write it out because we're going to solve for n. So now we can sub in everything we've got, leaving n as n. So we've got one unknown, and that's just n. So we got to try to figure this out. So let's just simplify first. So I'll distribute this 4 in. So 10 minus 4 is 6. Oops, let me fix that. And so what I can do is distribute this n over 2 in. So 6 times n over 2 is basically dividing the 6 in 2. So I get 3n. And then the next term I'm dividing the 4 by 2, so that's going to be 2, but I've got n times n, so that's n squared. So now we have some equation that has an n squared. I'm going to move the 629 over, and I'll rearrange it so that it's in standard form. And what we have here is everyone's favorite, which is a quadratic. And in order to solve quadratics, so I'll do that over here, to solve quadratics, we have two ways of doing that. One is to factor or the quadratic formula. So again, we're looking for n. In order to solve n, we have to do this because we have an n squared. So in fact, you cannot factor this one. It's numbers will not work. But what we can do is use the quadratic formula. So I'm going to get that one. So we've basically got n equals negative b plus or minus square root of b squared minus 4ac all over 2a, like that. So I'm going to give you the answers rather than go through the whole process of subbing in and solving. But basically this is a, b, and c. So hopefully you remember that stuff. And so we get n is equal to 17 or n equals negative 18.5. And so logically, we can only have a positive number of terms. We can't have negative term or number of negative terms. And so therefore, there are 17 terms. Like that. So a lot of the times you'll be able to factor, and that'll be much easier, but unfortunately for this one, we had to use quadratic formula. I think the one in the homework or in the you try, you'll be able to factor. So the next one's just an application problem, excuse me, where I don't know if you've ever been at a concert or something or theater and you look around and you're like, how many people are in here? And you try to estimate it, how many there are. Well, now you kind of have a way to do this. This one says an auditorium has 20 seats in the first row, 24 in the second, and 28 in the third, and so on. And it has 30 rows of seats. How many seats are there in the theater? So we have this pattern going on where we've got 20, next one 24, 28, all the way 30 of those. And so basically my A value is the first row, which is 20. My difference is going up by 4, and N is 30. So I have this where I can just simply plug this into my formula. Oops. And solve. And you can try that, see what you get here. I got 2,340 for the sum of the first 30 rows. So therefore, there are that number of seats in the theater. Done. Okay, so really you can categorize all these questions into these different examples, but why don't you try the